Okay.
Okay, good evening, everybody. So today we'll be discussing on the primer design work. So basically, what we've done is we picked E. coli as our organism, and the software that we use. I've tried Primer 3 Plus, and I've also, but mainly I will use NCBI as it has databases already implemented in the software, and of course it is very fast and I would say very accurate as it makes 10 pairs of primers at the same time, both forward and reverse. And these are some of the genes that we agree to do, and of course their origin sequence. So we will start off with HYLA gene.
Hi, my name is Nur Adina Patricia and my matrix number is 229363. So today I will be presenting my primer design for the detection of HLYA gene. First, this gene encodes for hemolysin A and primarily found in E. coli. While many E. coli strains are harmless, the HLYA gene is critical virulence factor found in pathogenic strain. So for this project, we use the accession number, which is NC0079461 as my reference sequence. So why is the gene is very important? Because HLYA gene is in E. coli encodes alpha hemolysin, a toxin that damage host cell membranes. This toxin form pores in cell membrane, causing cell lysis and tissue damage. The HLYA gene contributes the virulence of pathogenic E. coli strain and is commonly used as molecular marker in PCR based detection of pathogenic E. coli. So as you can see in the screen, this is the origin sequence. From this, we have designed a specific primer pair. First is forward primer, which is have 20 base pair long. Second, reverse primer also have 20 base pair long. Together, these primer are predicted to produce a PCR product size of 321 base pair, which is manageable size for clear visualization on a gel. Next, to ensure the PCR successfully and specific, I we analyze the primers based on four key criteria. First is melting temperature and annealing temperature. So for this primer, both have similar temperature, melting temperature, which is approximately 60 degrees Celsius. So this allow efficient and synchronous annealing. Next, the second one is primer length. Both have 20 base pair, which is optimal for specificity and efficient binding. The third one is percent GC content. They have 50% GC, which is within ideal range. Uh, so it can ensure stable primer template binding. Lastly is stability. The values are low under 7 for general and under three for three prime n, means that the primers are unlikely to stick themselves for or form the habit. Uh, that's all from me. Next.
Hi everyone. My name is Janani Anam Perempuan Murugan. My metric number is 229514. For this assignment, we selected the Escherichia coli GALK gene, which encodes the enzyme galactokinase. This enzyme plays a key role in the Leloir pathway, where it catalyzes the first step of galactose metabolism. The full-length gene sequence was obtained from the NCBI database using accession number, which is DQ361873.1 from E. coli strain 1708, and this sequence was used as the template for primer design. So this is the origin sequence. Moving on to the primer design. Our forward primer sequence is this, and the reverse primer is here, this one. Both primers are 20 base pairs long, which is ideal for achieving high specificity without compromising amplification efficiency. Each primer has a GC content of 55%, which falls within the recommended range for stable primer template binding. A key advantage of this primer pair is their closely matched melting temperature. The forward primer has a melting temperature of 58.98 degrees Celsius because the forward primer has a melting temperature of 60.03 degrees Celsius, while the reverse primer has a melting temperature of 59.98 degrees Celsius. Because these values are nearly identical, we can use a single annealing temperature of approximately 55 degrees Celsius, calculated as about 5 degrees lower than the average melting temperature, ensuring efficient and synchronized annealing during PCR. In addition to these basic parameters, we evaluated the primer stability to avoid common PCR issues. Both primers show low self-complementarity and, more importantly, very low 3' self-complementarity. With the forward primer having the value of 0, this greatly reduces the likelihood of primer-dimer or hairpin formation, which could otherwise interfere with the amplification. We also observed the presence of GC-rich bases near the 3' ends, forming a GC clamp. This enhances binding stability and allows DNA polymerase to efficiently initiate extension. To confirm the specificity, we validated our primers using NCBI Primer Blast. The analysis predicted a single specific 154 base pair amplicon from the GALK gene. The primers showed specific binding in reference to E. coli genomes such as K12MG1655 and O157H7 Sakai. No significant off-target amplification was detected, indicating high primer specificity and validating the suitability of this primer pair for reliable quantitative real-time PCR, qPCR applications. That's all from me. Thank you.
So hello, my name is Durna Josh Amina binti Muhammad Shafawi. My matrix number is 230918. I will reviewing the design for primer pair 1, which has been developed to target the Escherichia coli strain K12 substrain MG1655 genome. Our goal was to design highly specific primers for a rapid PCR assay, resulting in a predicted product length of 82 BP. This short product size is ideal for efficient amplification and clear visualization. So moving on to the our forward primer, please. Yes. So the sequence is As you can see, that is the sequence. So the length, it is 20 BP long, which is the optimal length for ensuring specificity and efficient binding. So next, the GC content. It has 55% GC content. Also, the melting temperature, TM, is 59.19 degrees Celsius. Moving on to the reverse primer. Similarly, the reverse primer also matches these high standards. It is also 20 BP long, a slightly lower 50% GC content than the forward primer, but it still falls within the ideal 40 to 60% range for stable binding lah. So the melting temperature it does not fall far from the forward primer, which is 59.97 degrees Celsius. So the annealing temperature, it is one of the most critical factors for a successful PCR because both primers have very similar melting temperatures around 59 degrees Celsius, right? So we can achieve efficient and synchronous annealing during the cycle. We have identified an operational annealing temperature range of 52 to 57 degrees Celsius with a recommended starting point of 54.2 degrees Celsius to maximize yield and specificity. So what does this mean is we should start the annealing temperature at 54.2 degrees Celsius, but the starting range should be 52 until 57 degrees Celsius. So next I will be moving on to can you scroll to for the primer stability and quality control. Beyond temperatures, we must also ensure that these primers won't interfere with themselves. Our analysis shows high stability at the 5' and 3' ends, which is first, self-complementarity. Both primers score lower or equal to 7, indicating a very low risk of forming internal structures. Next, 3' self-complementarity. This is even lower at lower or equal to 3, which significantly reduces the formation of primer dimers or hairpins. These low values ensure that the primers are available to bind to the template rather than each other. So this is quite the important factors. So in conclusion, this primer is a robust choice for targeting E. coli with balanced GC content, matched TM values, and low self-complementarity. We expect a clean 82 BP product at an annealing temperature of approximately 54.2 degrees Celsius. So that is all from my part for Lexigene.
Okay, so in conclusion, our team has carefully designed and evaluated the primer sets for HYA, DLK, and of course Lexigene to ensure that they will work reliably in the lab for a PCR experiment. So we've also taken into the consideration of the annealing temperature, the length, GC content, and of course we prevent self-ligation, which is the most important one, to increase the yield of the product. So I would say it is quite a fun experiment to do, and we are quite confident in the design because of we very appreciate with all the database that they have given us, that they have uploaded for the public to use. So I do have to give credit to NCBI and of course most other scientists who did all the DNA sequencing so that we can finish this primer design today without having to swap for our own E. coli. So thank you everyone. My name is Hector Chua. My matrix number is 230582.